Welcome at Ask the Professor for this MOOC of Railway Engineering at TU Delft. I'm really happy to see you with all the questions I saw on the forum. I really appreciate, and I also see some other students are willing to share the information and the answers. So it's really good that other people will work on that, and that's what we like, of course. And I think to have an introduction now is about how much questions I got already about the future, like the Hyperloop, what about automatic train operations. And I think it's really good, but that will become at the end of the Ask the Professor, so I will be back on with these questions, and when you like to answer it at the forum, be my guest, of course. So another question was about professional education. I think a lot of questions are really in depth. Maybe you are already working in the area or in the business. Really good, but I think it's better to go on with the professional education, and you can find that on the online education website of TU Delft. I'm sitting here at the Laboratory of Railway Engineering, and I'd like to go on with the first question. The first question I got was about adhesion and friction. What's the difference? I think I can explain a little in a little time, but okay, let's see how far I can come. Therefore, I'm sitting here on the wheel set, because friction is the interface between wheel and rail. So how to manage that and how to see that. And of course, adhesion and friction is one connection. Friction is the system of two rolling bodies or two bodies rolling after on each other, and adhesion is just one part of the friction, named adhesion, and you also have slip. And adhesion and slip in that together inside the contact patch, just in the wheel where I'm sitting here, that's exactly the friction as a system, the friction approach, and that's how we explain that. Hopefully you will understand, and if not, maybe not, send another question and see if you can, I can help you on another way or maybe on the forum. And a question I got about ballast resistance is what I'm sending here at the laboratory of TU Delft, because I like to show you how to do the measurements of ballast resistance. I got this question from one of the students from Egypt. I think it's a really valuable question, because how to do it? I think you have many ways to do, but in a normal way you could say, okay, how can I make a measurement that fits the practice? And the only thing I can imagine is that you just say, okay, I pull on a sleeper connected to the rail, and I just pull this through the ballast. And the force you need, and you can measure also the replacement of the sleeper in the ballast. And that is a measurement, you could say, that amount of force gives that amount of movement of sleeper through the ballast. That's a way of to go on in the longitudinal direction. It's an easy test. You can do it easily by an hydraulic crane or whatever, and you can easily do the work also in all countries all over the world. That's how the measurement works. But maybe I can tell more, because when you have a curve, for example, then you also like to have more resistance in the ballast. So the best way is to get resistance in the ballast is just clean ballast, really hooked, because then it is really one unified working body. That's important. But also you need on this edge of these sleepers a way of a shoulder. And the shoulder means I get more ballast on the head of the sleeper. So when I have a curve and I push the full construction outside on the on the upper leg of the curve, then I push the full construction out of the curve. And how to make resistance on that side? So you could say, okay, I make a bigger shoulder of ballast on that side, or we use some anchors we put together with the sleeper. And explain that over here. Because when you have an anchor, and you can see this, that you can say, okay, when I have this one on the head of the sleeper, then you get some resistance when you have to pull. So when I put this one over here in the ballast, I get more resistance sideways when it is connected to the sleeper. So just an easy part into the sleeper, that anchor works perfectly. Good luck. Another question I got with the Ask the Professor MOOC, Railway Engineering of TU Delft, is about the energy. Is it possible that we have pantograph, the power line, the catenary, you could say? Is it possible to have here in Europe, for example, one united power supply, one voltage, for example. I think we have big dreams to say, yes, why not? And I think everybody would say, yeah, why not? Why not? We are not doing that. But it's a little more complicated than just saying, okay, we switch the voltage to one level and that's it. I think the question is also about investments, about business cases, politics. You also have to change all the locomotives, maybe also the power line itself, because a higher voltage means a smaller diameter of these wires. So there's a lot of things you have to consider. What would be the perfect voltage, you would say? I think that I cannot say that directly. It's depending on how much operating trains you have, how much freight trains, what is the capacity of the trains. So there's a lot more than just say, okay, just take 3 kilovolt or 1800 DC or 25,000 volts. I think the best way is, okay, what do you need, what is available, and what is the wish list? And the wish list, you could say in Europe, was in the past 25 kilovolts. So make your choice. Another question I got at Ask the Professor was about steam locomotives and how to make the power chain from motor to the wheels and how it was organized. And I think in the past they were just easy and smart thinking. And why not, I think? And I think we still have a problem with the modern locomotives because of traction control and all kind of electronics. It's the maximum power you get out, but we only have one contact patch, and that's this, the wheel on the rail, and that's always the same, and you cannot make it bigger. But in the past, they make it bigger because they have bigger wheels when they have more steam, more capacity out of the steam locomotive. You have 2 choices, or maybe 3. Remain the same wheel sets as you had before, but then you have slipping wheels, so you have misuse of your energy and capacity. The only 2 choices you can really use is more wheels, because then you have more contact patches, so you can put more power on it, or a bigger diameter of the wheels. And that's what you see on freight trains in the past when they have more engines, more steam capacity, so you need bigger wheels. Bigger wheel means a bigger contact patch, and then you can put more adhesion force and you get traction. I think that's the easy question, and when you look back, and that's a counter question to you, when you look back at the modern locomotives, I think we lost this system of thinking, and therefore we have a lot of problems with traction control, and you can get all kinds of defects on the wheel but also on the rail. Please think about that. The last question I had was about what about design rules and design ideas of the system to make the system complete or more optimized. I think that's a general question, and we already make that point already in one of the earlier Ask the Professor upload movies of this MOOC. So please look at that Ask the Professor history and catch this question if you like. At the end, I'd like to thank you all for the questions. I really enjoyed it. It was a long list and also some real good interaction between the students. I really appreciate it. So keep this spirit high and go on. Next time I will be somewhere in Holland on the operations sites. We look on operations and I will come back with your questions. So good luck and make these questions and send it to me. Thank you.